Hello, ladies and gentlemen. This is Mr. Green. This is another in my series of geometry videos. So I appreciate you being here and watching this. We are looking at lessons 1.10 and 1.11 today. Okay. Don't forget, make quiz corrections if you have any problems with any quizzes. Make certain you get them taken care of as quickly as possible. Reworking those problems will help you understand them much better. Okay. So what are we looking at today? We're looking at coordinates in 3 dimensions, three-dimensional coordinate systems. Okay. So when we look at three-dimension coordinate systems, just like in a normal coordinate system, there are 3 dimensions. First of all, we've got our x dimension. That will be this one right here. We've got our y dimension. It'll be this one right here, and our z dimension right here. Why do we have to have a three-dimensional coordinate system? We have to have a three-dimensional coordinate system anytime we're talking about plane flight, flying through the air, being airborne at all. You have to know how high you are up and what your x and your y coordinates are. Okay? Why do you need a three-dimensional coordinate system? Anytime we travel under the ocean, we have to have both our x and a y direction that we're going, and then how far down we are. Okay? All these things come into play when we're talking about the coordinate system. How do I know which is the x coordinate? X coordinate and y coordinate. It's always been left and right for x and up and down for y. And you've always looked at it and said, but that's what the x and the y coordinates are. Okay? But what you're looking at here is if you were looking from up here, so you've got a face looking right up here. Okay, let's see if I can draw a face here. Eyes, mouth here. You're up, you're looking right here. Okay? If you're looking down on this coordinate system, then this would be your left positive and this would be your right over here. I'm sorry, this would be your right direction here. This would be your left direction here, x and y. This would be your y negative, it'd be going down, and this would be your y going up. Okay? So if you were looking at this from as a two-dimensional thing from above, this is still the same coordinate system, still the x and y coordinate system that we have dealt with in the past. No change whatsoever. Okay? We just have added a third dimension going up and down, which is truly the up and down direction. And that's why we have a z direction in here. Now, in several movies, most specifically in The Wrath of Khan, which is a Star Trek movie, one of the ways that they capture the enemy and the good guys win is because they point out that Khan was very much a two-dimensional person, only dealt in an XY coordinate system, did not ever think about going up or down. And so they went down in Z direction and then came up behind him and were able to capture the bad guy that way. The whole point is, it is still something, even in fictional movies like that, X, Y, and Z are 3 dimensions that we need to make certain we understand. This is a very difficult concept for most people, and it is something that in past history, this concept of 3 dimensions has always been very difficult for them to people to understand, and they've made some very poor decisions in how they've dealt with it. I just want you to understand, if you go put your nose in the corner of the room, you've got 3 dimensions sitting there. You've got a wall on your right, a wall on your left, and the wall going in the corner of the room going up and down. So you've got an X, Y, and a Z dimension sitting right there. It's something that you're familiar with and you should be able to see. Okay? This relates to real life. You have to be able to understand this to be able to understand how things are put together. Okay? So if we're looking at dimensions like this, we're always going to list them as X, Y, and then Z. Okay? We're always going to list them as X, Y, and then Z. 2, X, 4, Y, 3, Z, 0. Okay? X, 3, Y, 2, Z, 4. Okay? Next one, X, 3, Y, 2, Z, 4. I'll leave the rest of these. We'll look at them later on. Okay? So if I'm trying to locate a point that is in three-dimensional space, first thing I'm going to do is I'm going to look at this first one here, 5. I'm going to go on the x-axis a positive 5. 1, 2, 3, 4, 5. I'm going to put a point right there. I'm going to put a y-axis, 3. That means it's going over in the y direction, positive 1, 2, 3. And then a z-axis of 4, positive z, 1, 2, 3, 4. It'd be right up here. So now that I've located those 3 points, I want to draw a line parallel to this one in space, out like this, parallel to the y-axis. I'm going to draw a line here, parallel to the x-axis. Those 2 points are going to meet right there. See where they meet? If I draw a line going up, the z, just like the z-axis does, from each one of these 3 things, so maybe Castle was right. If Donnie was desperate enough to sell his union card, maybe he fell off the wagon and got in over his head. Okay. Now I'm going to draw a line from this one out like this. You can see how I'm constructing kind of a polyhedron here a little bit, right? But what we're actually going to get is the location of that three-dimensional point. So I've drawn each one of those lines, okay? And I want to make certain I point where's the intersection of all 3 of those lines at. It's right here. This would be point A. That is the point that would be point A. These other lines that we've drawn in here could then be erased because all they were doing was helping me locate where point A is located. Okay? Now, that's all I'm doing is erasing the line. Now, I know that it looked like it is sitting right on that z-axis. It is not. It is sitting out in space there. Okay? And it's difficult for me to show this to you otherwise. But it is out this direction, and then we came this direction to here, and then we went up that direction. Okay? So that is where the point A is located at 5, 3, 4. That is the way you would locate any three-dimensional point that you are looking at. If you go over to the corner of your room, just like I said before, you've got 3 dimensions. You measure one way along the wall, 5. You measure along the other wall, 3. You look at where those 2 would intersect on the floor itself. That would be the point 5, 3. And then you go straight up in the air 4 units. That would be the point 5, 3, 4. It's important for you to be able to see how those are found. Distance formula. Distance formula works exactly the same way as it did in a 2-dimensional distance. You've got your change in your x's and your change in your y's. We simply add the change in the z direction to it, and it gives us a distance formula in 3-dimensional space for how far 2 points are away from each other, given those 2 points. Really easy to use, not a big deal at all. How would I apply this? Well, given these 2 points, S is located at 0, 1, 2. T is located at 5, 4, 3. I would take my x values here, 5 and 0. And I'm going to take 5 minus 0 and get 5 minus 0 squared. And I'm going to take the 1 and the 4. And I'm going to take 4 minus 1 squared. And I'm going to take the z values, 3 and 2. 3 minus 2 squared. Right? And I simply take each one of those. That gives me 1 squared, that gives me 5 squared, that gives me 3 squared. Well, 1 squared is 1, 5 squared is 25, 3 squared is 9, that gives me a square root of 35. That would be my distance that I would use for this line right there, that blue, line in blue. Okay? Midpoint formula, halfway between 2 points. Same thing as we did before for midpoint. You found the halfway point for the x, you found the halfway values for the y's. You're going to find the halfway value for the z, and that'll be the midpoint between 2 points that are on a 3-dimensional plane. So using those same points again, let's find the midpoint. 5 plus 0 is 5 divided by 2, that'd be 2.5. 4 plus 1 would be 5 divided by 2, that'd be 2.5. And 2 plus 3 would be 5 divided by 2, 2.5. My point would be at 2.5, 2.5, 2.5. And that would be locatable right there as the midpoint between those 2 points. Okay? So, three-dimensional, two-dimensional, done exactly the same way. We didn't really change anything. All we did was add a dimension to it. That's why this lesson is important, because you need to be able to understand how three-dimensional objects are put together and how we can use these same formulas in the use of three-dimensional objects. So we can find the three-dimensional distance. We can find the midpoint on three-dimensional objects. It becomes really important for us in future lessons. Okay? So these are the things that the Texas says we need to be working on. Exact things that we've been doing here today. Okay? So I appreciate you continuing to let me know that you are in geometry and what section of geometry you're in when you're sending me emails and K-mails and things like that. It helps me to locate information quickly and therefore be able to answer your questions quickly. I look forward to talking to you in Class Connect this week. Bye.